When we look around us, the Earth seems cool and solid. We see rocks, soil, oceans, and mountains. But deep below the surface, our planet is not cool at all. In fact, the very center of the Earth, called the core, is as hot as the surface of the Sun. Scientists estimate that the temperature of the Earth's inner core is between 5,000 and 6,000 degrees Celsius, about 9,000 to 10,800 degrees Fahrenheit. That is roughly the same as the temperature of the Sun's surface, which is about 5,500 degrees Celsius. This may sound unbelievable, but scientists have strong evidence to support it. No one has ever gone to the Earth's core, the deepest hole humans have ever dug. The Kola Super Deep Borehole in Russia goes only about 12 kilometers deep, which is just a tiny scratch on the Earth's surface compared to the nearly 6,400 kilometers to the center. So, how do scientists know how hot it is down there? They use indirect evidence. When earthquakes happen, they send out waves that travel through the Earth. By studying how these seismic waves move, bounce, and change speed, scientists can tell what kind of material they pass through, whether it's solid or liquid, and how dense it is. Using this information, they've built models of what the Earth looks like inside. The Earth has four main layers: the crust, the mantle, the outer core, and the inner core. The outer core is made mostly of molten, liquid iron and nickel, while the inner core is solid, made of the same metals but under so much pressure that they can't melt. The temperature at this depth has to be extremely high to keep the metal in these states. Scientists also use laboratory experiments to study how iron and nickel behave under pressures and temperatures like those deep inside the Earth. These experiments confirm that the core must be about as hot as the Sun's surface. There are several reasons the Earth's core is so hot. The first reason is leftover heat from when the Earth formed. About 4.5 billion years ago, the Earth was created from clouds of dust and gas. As small particles came together to form the planet, they released energy. This energy turned into heat, and much of that heat is still trapped inside the Earth today. The second reason is pressure. As you go deeper inside the Earth, the pressure increases because of the weight of all the layers above. The deeper you go, the more squeezed everything becomes. When materials are under extreme pressure, their particles move faster and generate more heat. This is why the center of the Earth is so incredibly hot. The third reason is radioactive decay. Inside the Earth, there are elements like uranium, thorium, and potassium. These elements naturally break down over time in a process called radioactive decay. When this happens, they release heat. This heat slowly builds up and keeps the Earth's interior warm, even billions of years after the planet's formation. Together, these three factors, leftover heat, pressure, and radioactive decay, keep the core burning hot even today. The heat from the Earth's core is not just interesting, it is also very important. This internal heat drives many of the processes that shape our planet. For example, the heat causes convection currents in the mantle, slow movements of molten rock that make the Earth's crust move. These movements are what cause earthquakes, volcanic eruptions, and the drifting of continents, known as plate tectonics. Without the heat from the core, the Earth would be geologically dead. There would be no mountain building, no volcanoes, and no renewal of the planet's surface. The heat also helps generate the Earth's magnetic field. The outer core, made of molten iron, moves around the solid inner core. This motion acts like a giant electric dynamo, creating magnetic forces that extend far into space. The Earth's magnetic field protects us from harmful radiation coming from the Sun, making life on Earth possible. When we say the Earth's core is as hot as the surface of the Sun, it might sound like the two are similar, but they are actually very different in many ways. The Sun's surface, called the photosphere, is about 5,500 degrees Celsius, similar to the Earth's inner core temperature. However, the Sun's center is far hotter, around 15 million degrees Celsius. That's where nuclear fusion happens, producing the energy that makes the Sun shine. The Earth's core, on the other hand, doesn't produce light or energy through fusion. It glows only faintly due to heat, but it's deep underground, so we can't see it. The heat in the core is more like the warmth of a furnace that keeps the Earth's engine running. It's amazing to think that beneath the cool ground we walk on every day lies a fiery heart, as hot as the surface of the Sun. Even though we will never visit it, the core affects everything about our planet, from the way continents move to the way compasses point north. The Earth's core reminds us that our world is not just a solid rock floating in space, but a living, dynamic planet with incredible forces working deep inside. In simple terms, the Earth's core is as hot as the surface of the Sun because of leftover heat from when the planet formed, the crushing pressure inside, and the constant release of heat from radioactive decay. This heat powers the movement of continents, causes volcanoes and earthquakes, and keeps our magnetic field alive. Without it, Earth would be a cold, lifeless rock.